Hey everyone, so let's take a look at now some of the G codes here in the NC part programming, and we're going to take a look at also some of the examples of how to write the NC codes. So to start off with G00, which stands for the rapid motion command, what it does, it basically moves the cutting tool from its current location to the next by defining X, Y, and Z words. So the G00 command is, a non-cutting, rapid cutter motion and cutter retract. The simple format is given as the N word, then the G word, which is G00 here, and then the X, Y, and Z coordinates. All right. So an example of this could be N01, G00, X 20.0, Y 30.0, and Z 1.0. So what it does is that it's on the right hand side, if you notice this simple graphical representation of this command is shown in the way that, let's say the cutting tool is initially located at 5 location at point A, and then we are trying to make it go to the point C, which is specified as 20 in the X and 30 in the Y from this command here. And this is the positioning tool, so it's not really performing any cutting operation. So it really depends on what path to take to go from point A to point C, which is typically determined by the machine controller. So it could go directly from A to C, or it could go first from A to B and then going from B to C. So it really depends on how the algorithm is set up in the machine controller. It usually does it by the incremental approach. All right, so that's the G00. Let's take a look at the G01, which is the linear interpolation motion. And this is a cutting operation. So in this case, it moves the cutter from its current location to the next by defining the X, Y, and Z words. G01 is, like I said, it's a cutting operation, and it always moves in the linear straight line. F is basically the feed rate. And so the format of that is, it could be as simple as N, then G01, then XYZ, and then F. So let's say you have this program block as N100, G01, and X20, Y30, and F3. F is basically the feed rate. It could be in inches per minute or millimeters per minute, or whatever the units it may have. So initially you're going from the location A55 to the new location 2030. It will follow the straight line path between these two coordinates, and then it will cut the material along this straight line. Okay, so that's the G01. Moving on to G02 /03, it's basically the circular interpolation motion. 02, if you specified 02, then it will be clockwise, or if you specify 03, then it's going to be counterclockwise. Obviously when you view it from the Z direction. All right, so this command basically instructs the controller to move the cutter from its current position to the next position along a circular path defined by the X, Y, and Z words. All right. So again, the example, if we want to look at it here, is N10, then G02, which means that we are moving, or basically cutting it in the clockwise direction, and then you have X, Y, Z, and then I, J, K, and then the feed rate. So X, Y, Z obviously represents the coordinates of the end point of the arc. Okay, so let's say initially the cutter is at location A with the coordinates of 10 and 20, and let's say we want to move it in the circular motion to the point B with the coordinates of 20 and 10. So how do we move that? What should be the radius of this arc? So X, Y, and Z, if specified, it represents the coordinates of the end point of the arc. So if you see here, 20 and 10, that's basically the coordinates of the endpoint where we want to move it to. And then I, j, and k are the incremental distance from its current position to the center of the arc. Okay, so that's how the I and j values are reported. If it's a planar, 2.5 axis mill, then obviously it's going to be moving it in a plane, x and y together, and so it will be only specified in I and j, but not the k value. So here, let's say I is -5 and j is -15. So from point A, it will go -5 in the I direction, which means the x direction, and then -15 in the y direction or the j direction. So that way, it's going -5, -15, and so you get the center of the arc. And from this point C, which is the center of the arc, then the cutter is going to be moving from A to B. Okay, fairly simple to understand this. It's just how you're representing the center of arc in terms of I and j and k. And also you can indicate the center of arc by using simply the radius of that arc, and you don't need to really do it using I and j. So how do we do it? We can specify by using different command here. So again, the same thing, G02 or 03, depending on if it's clockwise or counterclockwise. And so instead of using the I and j words, we can use the R word, which is used to specify the radius of the circular path with this G02, 03 commands. So for example, if you have G00, X 3.0, Y 4.0, which means that we are moving the cutter from whatever the location it was before to this point A at 3 for the X and 4 for the Y. And then we are specifying the command of G02, X -3, R 5.0. So we're not really specifying any Y coordinate here, which means the Y coordinate is going to be the same as before. And the X is now -3. So we want to move this cutter from A34 to B -34. All right. And then the radius of the arc is specified as 5. So you don't really need to, give the I and j values here. So where this radius 5 the center will be located for this radius 5 arc. So it could be either on this side or it could be on the lower side, right? So there are two possible locations for the center of the arc, and that you can see in both these figures. So the figure A shows the arc for radius 5, which means the center is somewhere here on the positive y-axis. But you can also create the same arc with the radius 5 if you move the center of arc at the in the lower part of this. Let's imagine if you draw the horizontal line with A and B. So the center of the arc could be either above this line or below this line. And if in this case, if it's below the line, it's at the origin here, obviously, because this is X is 3 and Y is 4. So obviously the radius is 5, which means the center of the arc is at the origin here. So that radius 5, it can create an arc again in the clockwise direction because it's G02. A longer arc here, right? Or the shorter arc can also be created if the center of the arc is located on the other side of this imaginary straight line A to B, right? So that's a shorter arc. So if you want a shorter arc, then you specify R 5.0, but if you want a longer arc, then you need to specify R -5.0. Okay, that's the only difference between the two different possible kinds of arc that you may want to create. All right, so the next one is the G12 13, the circular pocket milling. So 12 is for clockwise and 13 for counterclockwise, again when viewed from the +z direction. So this command provides a pocket milling of a circular shape, and the format is the N, and then the G12 or G13, then IK, L, Q, F, C, where I is the radius of the first circle, from the location that it starts, and then K is the radius of the finished circle. The L stands for the loop count for repeating, deeper cuts. Q is for the radius increment, and it has to be used with K. F is the feed rate, and then the Z is the depth of cut. All right. And so in this case, typically I, K, and L are used with the tool radius compensation commands G41, 42, so that the pocket of prescribed diameter can be maintained using the different size cutters. This is something we're going to take a look at it in the next few slides, because the tool radius compensation is really important, because when you want to use a cutting tool to, let's say, create a 3-inch diameter hole, then the radius of that cutting tool is also going to make that added extra diameter of the hole if your program path is exactly of the 3 inches in diameter. Then if the tool goes, let's say this is a 3-inch diameter hole, and if you want the cutting tool to follow this in the program path, this dotted circle, then obviously if this cutting tool's radius is going to create that extra depth the extra diameter of that hole. So that is very important to keep in mind, that we need to do the radius compensation when the programs are made. All right, the tool must be positioned at the center of the circle in this previous step, or at the beginning of the current step, and then the cut is performed entirely with circular motion of varying radii. So for example, if you look at the first example here, the tool path of circular pocket milling, it specifies G12, I equals to K equals to 3, or basically the program could be, let's say, G12 I3, let's say F10 Z negative 0.25. Okay, so in that case, what's going to happen is that since the K is not provided, then automatically I is equal to K, which is the radius of the first circle and the finished circle. And so now if you look at the first figure here, if the current position of the cutter is, let's say, 3, 3 here, you can see this graph here, and let's say this position is 3, 3, 3, 3. Then this NC block moves the cutter along the circular path 1A of radius 1.5. Okay, and then it follows the larger circle 1B. So it starts off with 1.5 here, and it follows the larger circle 1B, and then 2A of radius equal to 3 in a complete 360 degrees motion, and then 2B of radius 1.5. So it's 1A, then 1B, then 2A, and then 2B to come back to its original position. You can note that the tool paths of semicircles 1A and 2B are nothing but transitioning into the size of the pocket specified in I3 and back to the starting position respectively. So instead of the pocket, the cutter cuts a trajectory of 2 circles of depth 0.25, because let's say we specify Z equal to negative 0.25, then the depth of cut is 0.25. 1A and 2B of radius 1.5, and 1B and 2A of radius 3. All right, so that's all it's going to do it. So that is the reason why you need some increments when you in the amount of Q for the radius increment. Okay, so let's take a look at the second example on the right in the figure B. Let's say the command for that is, let's say, G12 I1 K3 Q1 F10 Z negative 0.25. So let's say we have I equal to 1, K equal to 3, and Q equal to 1. Okay, so again, we're going to assume that the current position of the cutter is at 3 comma 3, and then this NC block will move the cutter, by first it's going to start off with the semicircle 1a of radius zero point 0.5, all right, then followed by the semicircle 1b of radius 1, then semicircle 2a of radius 1.5, then 2b of radius equal to 2, because 1 plus q or 1 plus 1 equal to 2. All right, and then semicircle of radius 3a with the radius 2.5, then semicircle 3b with the radius equal to 3, then semicircle 4a again with the radius equal to 3, because now k equal to 3, and then semicircle 4b of radius 1.5. Okay, so that way it will from here, so 4b of radius 1.5, so it will come back to its original position, which is at 3 comma 3. Okay, so as you can see it from this second figure here, when we specify the value of q, we didn't specify that in the first one, so you can see that this cutter will cut a trajectory of 4 complete circles of the depth 0.25 with the radius that will vary from 0.5 as we started off with until the 3. Okay, so you can also note that if a cutter of diameter greater than 1 is employed, the NC block that will cut will cut a circular pocket, but the outer radius of the pocket is k plus the radius of the cutter. Okay, and so that's why we need to provide the radius compensation. All right, so that's the circular pocket milling. And now let's take a look at the template of a typical NC program. So typically you start off with a selection of the cutting tool with a T command and then M06. Then the next line could be to turn the spindle on and select the RPM, then turn the coolant on, then rapid to start the positioning of the part, which is G00, then choose the proper, not fade rate, it's a typo here, it should be feed rate, and make the cut. Then once all the cuts are done with the G codes, then you can turn off the spindle with M05 command, turn off the coolant with M09 command, and then return the tool for holding position and select the next tool. Okay, so that's the G28. These are basically the typical steps or a program that you use for doing the machining operation. All right, so in the next video we will continue with this and then take a look at some of the NC part programming examples. We're going to take a look at the trajectory milling. We will also take a look at another example of the profile milling, and also then we're going to look at the tool functions and compensations.